6, so I feel like I'll just get ahead of it and try to fine-tune it so you can have a little more luck with maybe the rest, or maybe these will be the only 2 and this will be the only video you get from me. But essentially when there's fractions within a larger fraction, that's our complex fraction, and my preferred method is always going to be clearing fractions. And this is always tricky no matter what, if you're in school live or out of school receiving instruction. It is just takes a while for kids to pick up on. So my advice is to clear the fractions, which means we're going to find a creative way to multiply by 1 so that we change the appearance, but we do not change the value of the fraction as a whole. And to figure that out, I'm going to look at all of the mini denominators within the mini fractions. Now this one on 55 only has 1 mini fraction, and therefore the only denominator, and therefore the least common denominator, is 3. That then is going to be what I multiply the top by and what I multiply the bottom by. Now, in our numerator is where we're clearing the fraction, so we definitely need to distribute that. Now, when you distribute the 3 to this first fraction, this 3 will cancel with that 3, leaving you with just x, hence the name cleared fractions. And then 3 times negative 1 will be minus 3. Now, typically, I don't distribute in cases where there wasn't a mini fraction to get rid of. So, and the reason that's going to help, if I just keep the 3 separate from the x minus 3, is because I'm going to see an ability to cancel x minus 3 over x minus 3 is just 1, making this answer 1/3. So I do distribute where there was an intent to clear a mini fraction, but I do not distribute there so that I can see that factor canceling. Let me just check the back of the book to make sure that's the version of the answer that you're looking at, and I wouldn't expect it to be any different. 1/3, and then yeah, they include what can x not equal. If ever something is a part of a denominator, like this is part of the whole denominator, x cannot equal 3, and that's why we have that, because if x did equal 3 from the beginning, immediately this would be undefined. And then in 61, which has, again, only 1 mini fraction right here, the denominator is not a fraction, it's just a binomial. So of the mini fractions within this problem, there's only one of them. The denominator, therefore, then is the only, it's the only denominator, so it's therefore the least common denominator. So that's what I'm going to multiply the top by and the bottom by. Okay, now my intent to clear a fraction is happening up here, so I am going to distribute up top. So that's going to be x times x minus x plus 3 minus, when I do that distribution, the x plus 3 and the x plus 3 are going to cancel, leaving us with just minus x. All over, and down here there was nothing to clear, so I'm just going to keep it x plus 2 times x plus 3. Now there's some cleanup that has to happen in the top. I'm going to distribute my x squared plus 3x minus x over x plus 2, x plus 3. And that's going to be x squared, 3x minus x is plus 2x over x plus 2, x plus 3. And then I'm going to head back this way and take out a GCF, x plus 2 over x plus 2, x plus 3 results in cancellation. So our final answer is x over x plus 3. And some of our values to be excluded, x cannot equal, again, anything that would have zeroed out a denominator. So this mini denominator would have been zeroed out if x was negative 3, so we can't have that. And the overall denominator would have been zeroed out if x was negative 2 or if x was negative 3. We don't need to list negative 3 twice. So that would be your final answer for 61. And again, let me just check it quickly to make sure. X over x plus 3, x cannot equal negative 2 or negative 3. So that is your quick little tidbit. Those questions I've gotten a couple times already, so I'm just going to get that out.